Good day, 20-1s. Welcome back to the fourth lesson of sequences and series. Lesson 2, working with geometric. So, arithmetic, we have a D value, a value that we add or subtract in a list of numbers to get to the next value. So here is an arithmetic sequence because we are adding 4 each time, so our D value is 4. Yesterday, we looked at geometric sequences, having a list of numbers that we multiply to get from number to number. So here, to get from number to number, we're multiplying by 2, so that was our R value, common ratio. Well, today we're going to keep working with this idea of geometric, but we're going to a geometric series, which again, if you recall from arithmetic series, is taking a geometric sequence, but instead of just having a list of numbers, we now want to end up with the sum of that. So, sequence, list of numbers, series, where we take that sequence, but we're going to add it to come up with a sum. So that's what we're going to be looking at this lesson. With geometric series, at this point, what's nice is we don't have a lot of new variables. We've worked with just about everything now. However, we have 2 formula that were new to us, but using variables we're familiar with. Both of these are solving for S of n. If you recall, capital S means we want the sum of a set of numbers. And in this case, as we start to look through, we have to decide, are we looking at a sum for a geometric or sum of an arithmetic? Both formulas have the R value in it. And the R tells us, well, we're dealing with geometric because there's a common ratio. So R is our common ratio. What we're multiplying by. We could be multiplying by a negative. We could be multiplying by a fraction. If you recall from last lesson, we can always calculate an R value by taking a term, term 4, and dividing it by the previous term. And that'll tell us what our R value or what we multiplied by. So any value to get the R value, take any term. We could take term 76, divide it by the term previous, and that'll be the R value. So that's what we're looking at with the common ratio. N continues to represent the number of terms in our series. T1 is the first term. Knowing what we're starting with is always beneficial. So there's 2 new formulas using the same variables. If we take a look at the 2 formulas, which one's nicer to work with than the other? Well, I'm not sure it really matters. The big difference, though, is here in the second equation, we have to know the last term. If I want the sum of the first 73 values, we have to know term 73. If we don't know what the last term is, well, then equation 1, because equation 1 just utilizes term 1, the common ratio, and the number of terms. Big thing here is when we look at sum where we start to work with fractional values is effective, productive use of our calculator. So we'll see that in a couple minutes. So on page 16, it's asking which are geometric series, and if it's a geometric series, then what is the sum? So, as always, I like to start by writing down the information I know. I know that term 1 is 5. We're trying to find the sum of the first 7 terms, so I know that the number of terms is 7. We don't know. We have term 1, 2, 3, 4. We don't know what the 7th term is, so I can't work with T of n. What's the other piece of information that we can get from this? Well, I can figure out the R value. First term is 5. Second term is negative 30. Third term is 180. Fourth term is negative 1080. So I want to make sure I have a geometric series, so I have to check a little bit. First things first, R value. Well, I can take negative 30, divide by 5. Term 2 divided by term 1 gives an R value of negative 6. Well, what's 30 times negative 6? 30 times negative 6? Negative 30 times negative 6 is positive 180. 180 times negative 6, negative 1080. So we definitely have an R value of negative 6. This case, yes, we have a geometric series, so we want the sum of it. Well, we have two formulas. When I look at the two formulas, remember we just talked about the fact that the second formula requires that we know the T of n term. In this case, we don't know what T7 is, so I need to focus on the first equation. The sum of the first 7 terms is going to be term 1, 5, times the R value, which is negative 6, exponent n, which is 7. But stop here and be careful. Understand, anytime I have a negative base, I need that base to be in brackets. I need, when I do this calculation, to have negative 6 times itself 7 times. Negative 6 to the 7. If I don't put the brackets in here, and I just have negative 6 to the 7, technically this calculation would be negative 6 times 6 times 6 times 6, 7 times. So we have to make sure anytime our base is negative, put it in brackets. So continuing, term 1, 5 times negative 6 to the 7 minus 1 all over R, which again is negative 6, minus 1. There's the calculation we have to do. Now, order of ops. We have to be careful to follow order of operations. Some of you might choose to try to plug this entire thing into your calculator at once. If you want to do that, that's fine, but make sure you put in appropriate brackets. You would need to put brackets around the top calculation, then hit the division, and then put brackets around the second calculation. If you don't put these brackets in the right spot, you're not going to get the right value on your calculator. Personally, I just like to look at what I have and break it down on my calculator. So my calculator would tell me, or order of ops tells me, I need to do brackets first. So I would need to do the exponent, then subtract 1, then multiply all of that by 5, excuse me, and then finish by dividing by the bottom value. Well, negative 6 minus 1, I know that's a negative 7. So I can do that little calculation, which will make it easier. So I like to break it into steps at a time and punch that into my calculator instead of everything at once. So it tells me bracket negative 6 exponent 7. That's our first calculation. I hit enter. My second calculation was to subtract 1. Hit enter. My next calculation was to multiply by 5. Hit enter. And I finish that dividing by negative 7. So if I identify each step that I need, I can get to a final value. What's our answer? The sum of those terms is 199,955. So S of 7 is 199,955. That's the value of the first 7 terms for that series. Breaking my steps down on my calculator. Big formulas, you have to make sure you're following order of ops. Don't just write down what I do. You need to make sure you can do this with your calculator. Question B. Well, question B, term 1 is 3. We know we want S of 13, so the number of terms is 13. Geometric. 3 to 5, what do I multiply by? That's ugly. 5 to 7, 7 to 9. Wait a sec, I'm adding by 2 each time. R value, not applicable here. This is not geometric, so I'm not even going to keep going because the instructions were, which are geometric, and what are the sums of the geometrics. So B, it's not even a geometric, I'm not worried about it. All right, working now with C. Let's take a look at C. What do we have? Term 1 is 4. We want the sum of 9 terms, so the number of terms is 9. What's our R value? 6 divided by 4. Well, 6 divided by 4 doesn't work nicely, so I just reduce. We have 3 halves. Let's double check though. 9 divided by 6. 9 divided by 6, reduce it, we get 3 halves. So we are looking at a geometric with an R value of 3 halves. So here we go. Looking at which equation. Again, in this case, we don't know the 9th term, so we need to work with that top formula again, because the top formula doesn't involve the T of n, so we can work with it. So here we go. We have sum of the first 9 terms is going to be term 1, 4, times our R value, which is 3 halves. All of that needs to be to the exponent n, which is 9, subtract 1. There's my numerator. And I'm dividing that by R minus 1. So there's my formula. Now I need to plug that into my calculator, break it into order of ops. First thing I'm going to do, 3 halves in the denominator here. 3 halves, subtract, turn the 1 into 2 halves because that's equivalent to 1. 3 halves minus 2 halves, I know that's a 1/2 value. So my last step will be to divide by 1/2. I'm going to do the exponent in the brackets. I'm going to subtract 1. I'm going to multiply by 4, divide by 1/2. Punching that into the calculator carefully, but I don't want to do it all at once. Make sure you can use your calculator effectively. Bracket, 3 divided by 2. There's my 3 halves, and I want that to exponent 9. There's my value. From there, I subtract 1. There we go. Then I'm going to multiply that by 4. There we go. And I'm going to divide that by 1/2. And I get 299.546875, blah, blah, blah. At this point, we don't want rounded answers. A lot of people would say, oh, that's 299.55 if I round it to the 100th place. Or just decimal 5 if I round to the 10th place. We have to be prepared to give exact answers, not rounded, which means we need fractional form. Remember, to turn an answer into a fraction, we hit the math button on our calculator. Number 1 right there that's highlighted says, hey, make it a fraction. So I'm going to hit enter. Our answer is going to become a fraction. I hit enter, and there I go. 19,171 over 64. There's the S9 value. 19,171 over 64. So there's the process for calculating sums for a geometric series. I'm not going to worry about question D. You can practice it if you choose to. Page 17, determine the sums. Big difference here is that we're determining the sums now. However, we know what the last value is. So having T of n is beneficial. So let's take a quick look. What do we have? T1 is 5. What's the R value? Well, R value here is pretty easy to figure out, hopefully. 5 to 15 is times 3. 15 to 45 is times 3. There's our R value. But now we can also plug in the last T of N term, which is 10,935. We don't know how many terms there are. We're not sure. We know there's term 1, term 2, term 3, whole bunch of terms till we get to term N. We're not sure what it is, but that's okay because we don't need to know what N is in this case. We just want the sum of all the terms. In this case, this formula is our R value 3 times the T of N, 10,935, minus term 1, which is 5, and that gets divided by R minus 1. There's our substitution into that formula. Again, lots of steps, fractional form, a lot more work than just punching in two numbers. Break it down on your calculator. If you want to punch it all in at once, you go for it. I don't trust myself. I'm going to multiply, and then I'm going to subtract, and then I'm going to divide all of that by 3 minus 1, which is just 2. 3 times 10,935 minus 5 divided by 2, our S of N for this particular series is 16,400. There's the sum of the values. So, all formula-based formulas are given to you, but it's the fact that you need to put some time in to figure out exactly what are the values. Now B, lots of fractions in this one. I suggest pause the video, give B a try, see what you come up with. A lot of little calculations in this one, a little bit ugly to do the final calculation because of fractions and things, but you got to get good at this. Pause the video, give it a try, and then we'll do it together quickly. All right, here we go. So to start with, term 1, negative 686. What else do I know? I know the last term in this case is a negative 2 over 343. What else do I know? Well, I can figure out the R value, because the R value is, one way to do it is 98 over negative 686. In that case, if I divide it, it's an ugly decimal, but 98 over 686, what I can do, well, what if I just write it as a fraction? 98 divided by 686, I hit enter, but you know what? I want it as a fraction. I want to work with a exact value, 1/7. So we see that it's 1/7 there, but again, it's 998 by a negative, so our R value is negative 1/7. I want to double check, so I'm going to take my negative 14 and divide it by the previous value, which is 98. Well, what's 14 divided by 98? Really quickly with my calculator again. 14 divided by 98. Enter. Look at that. It's the same thing. Same decimal value, so we know it's the same exact value. So we are good to go with that. So here, negative divided by a positive, we have an R value of negative 1/7. Quick check, make sure we know and we have a geometric series. So we have the T of N, so we can use the second formula. The sum of these is going to be our R value, negative 1/7, times the last value, negative 2 343rds. Subtract term 1, which is negative 686, and all of that is going to go over R minus 1. So again, I'm going to have to do this work on the calculator carefully. But before I do, my denominator, negative 1/7, subtract, this is 7/7, negative 1, change, Well, my denominator value is a negative 8/7. That's what I know I'm going to divide by to finish. The other one, if I'm subtracting a negative, if it helps, that's a change. We're just adding 686 there. So what am I going to have to punch into my calculator? Multiply those values, two fractions, watch the negatives. Then I'm going to add 686, and then I finish by dividing by negative 8/7. So here we go on our calculator one more time together. Make sure you can do this. Make sure you get the right answers yourself, not just by copying me. So we have bracket. We need a negative 1 divided by 7. There's our 1/7. And I want to multiply that by a negative 2 divided by 343. There's my first multiplication value. From there, we're adding the 686. Boom, there that is. Now we divide by a negative 8/7. Again, fractions in brackets. Negative 8 divided by 7. Enter. What did I do wrong? Oh, my negative 8/7. That's just ugly. So that means I want to go up and I'll grab this answer again, highlight it. There's what I want. And I want to divide that, again, in brackets by negative 8 divided by 7. There, that's a little better. Divided by that, hit enter. Negative 600, decimal, blah, 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 blah. Exact value. Math. We want math frac, which is highlighted. Enter. Please turn it into a fraction. This time it didn't do it because of my mess up. So it will go to a fraction, but I have to start over. Sorry about that. My bad. It happens. So again, at least I could see where my error was because I broke it into steps. So here we go very quickly. Negative 1/7 times negative 2 over 343. There's my first calculation. Perfect. Then we added 686. Boom, there we go. Then I divide by, let's be a little more careful with it this time, negative 8 divided by 7. Enter. Now let's cross our fingers. Math, please turn it into a fraction. There we go. Exact value instead of a rounded answer. 205,886 over 343, and it's a negative value. So the sum of this, negative 205,886 over 343. Using the formulas properly, understanding the values that are given in the question, and calculator work. It's all important. Here we go. Now we're getting some questions. It's not always about solving for S at n, because in this case, we're given S at n, but it wants us to find something different. So set it up, same way we have been doing, but now we're going to have to do some algebra. So what do we know? We know S of n is 605. We know that R is 3. We know the last value is 405. But it just has n's. We don't know how many terms there are, and we know we're trying to find the first term. So which formula can we use? Well, if I look at the first formula, we have S at n, we have the first term, we have the R value, but we don't have n. So we can't use that because we don't know what n is. Second formula, we have S at n, we have the R value. We have the T at n value. We have trying to find term 1, but we do have the R value. So there's the unknown we're trying to find. Second equation will allow us to do that. Everything's listed. Here we go. S at n is 605. It equals R 3 times T at n, which is 405, minus T1, which is what we're trying to find. All of that's being divided by 3 minus 1. So now we have to do some algebra, but we've seen things like this already. We have to get the T1 by itself. Well, we know our denominator is 3 minus 1, which is really just 2. I'm going to get rid of that denominator right off the bat, multiplying by 2, which we've seen in an earlier video. Divide by 2, so we multiply by 2. Same thing to the other side. Be consistent. We end up with 1,210 equal to, well, at the same time, I can do my multiplying up here. I end up with 1,215 minus the term 1. Get T1 by itself. T1 ends up being, I'm going to subtract 1,215, but that still leaves me with a negative, so I'm going to have to change my sign. Negative T1 equals 1,210, subtract 1,215, negative 5, but make my T1 positive, so I make the other side positive. Term 1 is 5. Right equation, substituting in, and a little bit of algebra. So example 4, a lot of information given to you. In this case, the question says how many terms. So we're trying to find the number of terms n. Going back to our formulas. Well, which formula are we going to use? Well, if we're trying to figure out the number of terms, and n's not even in the second equation, that doesn't help me because I need to know n. So pause the video, use equation 1, see what you come up with for the number of terms for the geometric series in example 4. Give it a whirl. All right, here we go. Trying to find the number of terms. What do we know? We know term 1 is 2, not a problem. We know the sum of all the terms. It tells us this time. Not directly, but here's our series, and it tells us our sum. So we know we're dealing with 39,062. What else do we know? Well, 2 to 10 is times 5, 10 to 5. Well, we know we have an R value of 5. There we go. So with that being said, well, now we want to work with the first equation. So we take S of n, which is 39,062, equal to term 1, which is 2, times the R value, which is 5, to the exponent n, we don't know, subtract 1, and all of that is over R minus 1 or 5 minus 1. First equation, substitute in what we know. Now we need to solve for the 5. Well, 5 minus 1 in the denominator, we know that's a 4. So I'm getting rid of that denominator right off the bat, multiplying by 4. We end up with here 156,248 equal to 2 bracket 5n minus 1. Well, we need to isolate the n. What can I eliminate first? Well, divide by 2 because it's not very close to that n, so we divide by 2. Now we're at 78,124 equals, we're left with 5n minus 1. Well, I can get rid of this 1 by adding 1. So we now have 78,000. I'm going to actually just move, running out of space here. Going to move up here. If I add 1 to the left, 78,125 equals 5 to the n. How do we calculate and figure out what an exponent is? The only way to get an exponent is to guess and check. So 5 to something will equal 78,125. So on our calculator, 5 to the something, let's try 10, 125. That's too much. So let's try 5 to the 8. 390,625. Still too many. So let's try 5 to the 6. 15,000. We went too low. Let's hope 5 to the 7 works. 5 to the 7, there's our 78,125. So guessing and checking tells us that our n value is 7. There are 7 terms in this series to get a sum of 39,062. Know what you're given, know which formula to use, and then have fun with some algebra. All right, just a couple more left. These ones, maybe a little bit more thinker. Example 5. Arithmetic series, we had a similar question to this. I really like this question. Doesn't give us a lot of information. We know that term 1 is 9. What else do we know? We don't know the sum. We don't know the last term. We don't know how many terms. Do we know what R is? Well, we can get R here. 9 to 15, well, that would be 15 divided by 9. Doesn't divide even, so I'm just going to reduce. We know that the R value is 5/3. Well, I have a lot of things that I don't know in this question. But if I know the R value, remember the R value here is going to be the same as the R value here. Well, how did we calculate R? We did 15 over 9. That equaled R. Well, what else will calculate R? Well, taking the third term and dividing it by the second term. So term 2 divided by term 1 will give us R, which we should also get by term 3 divided by term 2. Since those two give the same value, look at that. I've set up a proportion. I just have to cross multiply. Because this is R, so they're equal. How do we cross multiply? Multiply what we can. 15 times 15 is 225, and that will give the same answer as 9 times 3x plus 7. Cross multiplying gives the same products. So 225 is going to be the same as 9 times 3x plus 7. We just have to solve for x now. Multiply. Get rid of brackets. Get x by itself. Going to subtract 63. And then I have to divide by 27. So 225 minus 63 divided by 27. That gives us an x value equal to 6. So let's do a quick check. I like checking. I like to be right. So if I put 6 in there, my series should be 9, 15, and if x is 6, 3 times 6 is 18. 18 plus 7 is 25. And the R value, 25 divided by 15, if I reduce, is 5 over 3, which matches my R value to start with. So x equals 6 gives me the right term to create the series. Whew. Love that question. Understand the relationship of R being the same every time. Question 6. Question 6. Well, here we're given the sum, asking to find T1. Well, pause the video, list what you know, figure out which formula to use, and do some algebra. And let's see if you're right when you come back. We'll do it together quickly. All right, here we go. What do we know? Tells us R is -2. Tells us the sum of the 7 terms is -254. But what else can I get from that? Knowing that we have the sum of 7 terms tells me we have n equal to 7. There's 7 terms. Is there anything else that we know? It doesn't, because we're trying to find term 1. As soon as an n is given to us, I look right away to equation 1, because equation 1 has the n as part of the equation, the formula. So do we have S at n? Yes. Do we have T1? No, but we're trying to find it. We have R, we have n, and we have R. So there's the formula we're going to work with. S at n, well, it's negative 254 equals T1, that's what we're trying to find, times R is negative 2, but again, bracket that because that's the base for the n, which is 7 minus 1. And that all goes over R, negative 2, minus 1. There's our setup. Fantastic. Got to solve for T1. Well, negative 2 subtract 1 in the denominator. That's a negative 3. I'm going to multiply by negative 3. Cancel that off. Multiply by negative 3 like we've been doing to get rid of the denominator. From there, we get 762 equal to T1 times, and I'm going to do this calculation as well. Negative 2 to the 7, subtract 1. Check in my calculator, I get negative 129 there. So I'm left with wanting T1 times negative 129, divide by negative 129 to solve. 762 divided by negative 129, well, it doesn't work even. So what do? Math frac, and our first term is 254 over 43. There's our term 1. There you go, using the right formula. So, last one, word problem. Similar to what we did with geometric sequences, but a little different. Read the question, think about it. I like to try to set it up as a series just so I can see what's going on. So as an ad company, you know there are 1,000 people on day 1. Term 1 is 1,000 people know about your product. The number of new people aware of your product increases by 40%. So term 2 means my 1,000 will increase by 40%. So what am I going to multiply by? Well, first of all, 40% is going to be decimal 40. That's 40%. But because I still had 1,000 people at the start, I need that 1 like we did with geometric sequences. So my R value is 1.4. 1,000 people knew about it. I multiply by 1.4 to know how many people now know about it for term 2. Well, term 2, if I really want to figure that out, 1,000 times 1.4 is going to be 1,400. That's how many people know about it. But the question is, how long did it take to get here? Well, it says that every 10 days it increased by 40%. So this was 10 days. So that means in another 10 days, I'm going to be at term 3. And I would have to multiply by 1.4. And we keep going. So the key is that after 100 days, so that means 10 more days, I'm at term 4, and so on. And eventually, after 10 days, which term will be after 100 days? Well, 10 days is term 2. 20 days total is term 3. 30 days total is term 4. 40 days is term 5. 50 days is term 6. So that means 100 days is going to be term 11. Figuring out which term is the trick here. And it's not just after 100 days, the number of people increased. So 1,000 people on the first day. And after 10 days, another 1,400. After another 10 days, another so many. I am trying to find the sum of all these. So what do we know? We know that R is 1.4. We know that term 1 is 1,000 people. We know the number of terms is 11. It's term 11 that we want to add all together. There's the information. Which formula? As soon as we have the n, we're doing the first formula. So the sum of all these people, there were 1,000 on day 1, term 1, and that was a 1.4 R value for 11 times. Subtract the 1, and that divides by R, which is 1.4 minus 1. So now, again, I need to plug this into my calculator carefully. Denominator, 1.4 minus 1 is going to be 0.4. And now I can substitute in my calculator. Do my exponent, subtract 1, times 1,000, divide by 4/10. S at n works out to be 98,739.129, blah, blah, blah. Well, we can't have part of a person, so that's where the word about comes in. About 98,739 people know on day 100 about the product. So, geometric series, just more formulas to work with, being able to work with them effectively, knowing what you have. There's your assignment in the textbook. Get some work done, practice, and have fun.